Good evening, friends. In the morning, I was in a position to post the first video which was delivered by me pertaining to the course Applied Thermodynamics. Anyhow, in that video which was posted today morning, we were in a position to know the importance of the first two modules, namely air power cycles followed by gas turbines. Okay. Anyhow, these two modules have been covered during February and March. You could gain the theoretical aspects followed by the analytical reasoning pertaining to these two modules. But on covering the first two modules in the course Applied Thermodynamics, let me tell the complete essence of the last three modules in the course Applied Thermodynamics. They are mainly gas or vapor power cycles. Second one is refrigeration and air conditioning, and lastly reciprocating air compressors and steam nozzles. Anyhow, in the first two modules, you have come across the five prominent air standard cycles, namely Carnot, diesel, Otto, dual combustion, and Stirling cycles. In gas turbines, you have come across the thermodynamic analysis by employing ideal Brayton cycle. So, on understanding the ideal and actual Brayton cycle, we were in a position to know the three prominent methods to improve the thermal efficiency of gas turbines. They are intercooler, reheater, and regenerative gas turbine plants. But now, when you need to take up the third module in the course Applied Thermodynamics, that is vapor or gas power cycles, the flow whatever I am telling now you need to follow. You know that to study gas or vapor power cycles, you should be aware that this has stronger relevance to thermal power plants. Okay. When you take up the subject, energy engineering or power plant engineering or environmental science, you will be learning the theoretical operation of thermal or steam power plants. But without knowing the thermodynamics of it, there is no point in learning the course. So, in learning vapor power cycles, you have to initially take up Carnot cycle. Anyhow, in learning thermal analysis of heat engines, we have come across Carnot engine. Likewise, in vapor power cycles and refrigeration, we come across the same. On learning a Carnot cycle with a TS plot and flow diagram, you will be learning Rankine cycle, reheat cycle, regenerative cycle, and combinations. Rankine reheat, then reheat regenerative, and finally binary vapor power cycle. Please bear in mind, when you need to take up the analytical aspects in vapor power cycles, the use of thermodynamics data handbook is very much mandatory. When you learn the basic thermodynamics, particularly in learning pure substances, ideal and real gases, you could use thermodynamics data handbook authored by B.S. Samaka and Nijaguna. But bear in mind, how exactly you could see the values of enthalpy, entropy, specific volume while learning pure substances. The same ideas will be encumbered even in vapor power cycles and refrigeration. So friends, if you need to know the analytical ideas, initially in vapor power cycles, you should be well acquainted with Carnot cycle, Rankine, reheat, regenerative, Rankine reheat, reheat regenerative. Please bear in mind the flow diagrams and TS plot have been clearly accentuated in the lecture notes, PowerPoint presentation, videos, and other related material. Please go in this order. To solve any problem, please bear in mind you will be using thermodynamics data handbook. So this is the essence of vapor or gas power cycles. But When you need to take up the penultimate module, the last but one module in Applied Thermodynamics, please bear in mind you will be learning refrigeration and air conditioning. So that is one of the hot favorites for any faculty member to teach that. Why? Because you know that globally there are many celebrated refrigeration and air conditioning industries. Even students will be offered very nice salary packages in those refrigeration and air conditioning industries. To go into that, don't you really think one should be well acquainted with the theoretical ideas of refrigeration and air conditioning? So, bearing that aspect in mind, the experts have incorporated refrigeration and air conditioning as one of the course content in applied thermodynamics. Bear in mind, in the coming semesters, refrigeration and air conditioning can be taken as an elective also. How exactly one has to learn refrigeration and air conditioning? Friends, refrigeration and air conditioning, they are like married couple. One is totally dependent on the other. Initially, to know the theoretical ideas, one should be aware of the definition of refrigeration. Then you will be learning the technical terms like refrigeration capacity, refrigerating effect, ton of refrigeration, coefficient of performance. Yes. But one thing I need to tell. While learning heat engines, you could take up temperature volume and pressure volume relations. But when you learned gas turbines, you are in a position to use temperature pressure relation. Why? Because in heat engines you come across compression ratio. When you come across gas turbines, you come across pressure ratio. Okay, so compression ratio for heat engines, pressure ratio for gas turbines. But once when you know Brayton cycle crystal clearly, there is absolutely no problem in learning refrigeration and compressors. What is the idea? Very simple. Even in refrigeration, we depend on pressure ratio. That means to say you will be employing temperature pressure relation. Okay. Alright. After knowing the technical terms, you will be learning three prominent classification. What are they? They are air refrigeration, vapor compression refrigeration and vapor absorption refrigeration. Remember, air refrigeration mainly depend on reversed Carnot cycle and reversed Brayton cycle. You are already aware of Carnot and Brayton cycles, but remember here the flow direction is reversed. Okay, that is why air refrigeration depend on reversed Carnot cycle and Brayton cycle, reversed Brayton cycle. But the technical jargon or nuance in the case of refrigeration for reversed Brayton cycle is Bell-Coleman cycle. Okay, please bear in mind Bell-Coleman cycle or reversed Brayton cycle. Anyhow, the material has already been posted. I hope you are learning that. You please bear in mind initially one should be well equipped with air refrigeration. If you know this, there is no problem in learning vapor compression and vapor absorption refrigeration. Friends, very simple. Learning refrigeration is absolutely easy. You may think that it is hard nut to crack, but there is nothing in this. Okay? If you know the concept of heat engines and gas turbines, refrigeration and reciprocating air compressors will be very easy. Okay? So, you will be learning air refrigeration, vapor compression and vapor refrigeration systems in refrigeration. So then the art of solving problems will be very easy. Why? Because even in solving problems on refrigeration, you will be employing thermodynamic data handbook. Okay? This is all about refrigeration. But when you need to come to air conditioning, the same order, the same flow you need to follow. Initially, principle of operation of an air conditioner. Okay? Then the technical terms associated. Okay, there are many terms associated in learning air conditioning processes. What are they? For example, you take up dry bulb temperature, wet bulb temperature, sensible heat factor, humidifying factor. Many things you come across. Okay, so the person responsible for inventing the first ever refrigeration was Jacob Perkins in 1834, followed by James Harrison. But in 1902, the first ever industrial based air conditioner was invented by Willis Haviland Carrier in 1902. Okay, that is why on every air conditioner at the bottom you can find Carrier. Who is that Carrier? One of the prominent inventors of industrial air conditioner. Okay, all right. After knowing these technical terms, you will be exposed to Carrier's equation later on. By using the psychrometric chart, you will be solving the problems on air conditioning. Okay, so all pertinent material pertaining to refrigeration and air conditioning has already been posted to all student WhatsApp group of 4th semester. Okay, so whatever order I have revealed for vapor power cycles and refrigeration and air conditioning, you please follow that. All right, so anyhow, we are through with first 4 modules in applied thermodynamics. Lastly, very simple, you need to come across reciprocating air compressors and steam nozzles. So what flow we need to follow, sir? Is there any particular order we need to follow? Children, yes. See, whatever order I am telling you, please take it as Vedavakya. Okay, so it will be very easy for you to comprehend in the examination point of view. While you take up reciprocating air compressor, you know that any application in thermodynamics, it has exorbitance. What exactly is that? Any application you take up, it has sub application. You know that heat engines, it has stronger relevance, gas turbines, then internal combustion engines, then analysis of vapor power cycles, then refrigeration, air conditioning. Each and every application has prominent application. That is why applied thermodynamics is one of the celebrated courses in mechanical engineering. Likewise, reciprocating air compressor, it has many applications. So what order you need to follow? Initially, you should be aware of the definition of air conditioner. Okay, so after knowing the definition of refrigeration, air conditioner, very similarly you will be aware of the definition for air compressor. Do you think air compressor is connected with refrigeration and air conditioning? Yes, definitely. All modules are interconnected. Heat engines, IC engines, they are connected. Gas turbine, jet propulsion, they are interconnected. Vapor power cycles, yes. Refrigeration, air conditioning and compressors, they are all interconnected. Okay, so you find compressor both in refrigeration and air conditioning. That is why one should be aware of the definition followed by the prominent applications of air compressor. Then coming to analytical idea, are there derivations in reciprocating air compressor? Yes, friends. Anyhow, we have done with a few derivations in the previous modules. In reciprocating air compressors, we find 4 prominent derivations. Which are the 4 prominent derivations? You please follow this order. Anyone can understand. Initially, you practice the derivation for work done by a single stage air compressor without clearance volume. Next, work done by a single stage air compressor with clearance volume. The third derivation is expression for volumetric efficiency for a single stage air compressor. Once when you are done with these 3 derivations, I can promise you, I can bet you that any numerical problem on reciprocating air compressor you can solve. So I have already posted the numerical problems pertaining to gas turbines, vapor power cycles, refrigeration, air conditioning and reciprocating air compressors. So I can promise you that. So before we start the next session of the classes, once when the college reopens, you will be habituated to any sort of problem in the course. Okay, so once when you are done with these 3 derivations, I can promise you that any problem on reciprocating air compressor, you can do it. Okay, all right. Once when you are done with single stage air compressor, you will be expecting one prominent derivation from 2 stage air compressor. Okay, that is expression for power delivered by a 2 stage air compressor. Very commonly they will be asking. Okay, yes. Now let me give a link. See, the great advantage what you will be having in learning gas turbines is, once when you learn gas turbines, you will be exposed to refrigeration. You can effortlessly understand refrigeration. Also, compressors will be very, very easy for you. Okay, that is why while teaching heat engines in the beginning week of February, I clearly told that three prominent relations dominate applied thermodynamics. They are temperature volume relation, pressure volume relation, temperature pressure relation. So temperature volume pressure volume relations you deal in heat engines, but temperature pressure relation gas turbines, refrigeration and compressors. You can effortlessly grab 60 full marks in the last three modules. Once when you are aware of temperature pressure relation. What is that? T2 by T1 equal to P2 by P1 to the power of gamma minus 1 by gamma. Okay. So friends, once when you are done with these four derivations, any problem on reciprocating air compressor, you can do it. Finally, we are coming to steam nozzles. Even I have posted the material for steam nozzle the previous week. Friends, let me tell you a secret. Normally, we cannot reveal any secret, but this is an open secret. To learn steam nozzles, please bear in mind, you should be aware of compressors. In compressors, we give the importance for pressure ratio. That means to say pressure at the peak, velocity at the lowest level. But in learning steam nozzles, we do not give importance for pressure. We normally emphasize on velocity. Okay, so bearing this in mind, we learn convergent and divergent sections in a nozzle. There is one prominent derivation in steam nozzle. When you practice that, problems will be dead easy. Okay, so with this, I think you are getting utmost clarity in the subject applied thermodynamics. Okay, so for another 2-3 minutes, let me summarize all information so that you can aggressively start preparing for internal assessment and examination. Okay, once when the college reopens, we can revise thoroughly. Also in future, we will be having online interaction classes, live videos, or the videos recorded by me you will be following in the WhatsApp group. So children, please remember few prominent relations. So let me just quickly run through. In the first module, you are aware of heat engines, thermal analysis of all air standard cycles. So you should practice the expressions for thermal efficiency and mean effective pressure for all cycles. Next, we could solve problems on internal combustion engines and air standard cycles. They are both interconnected. So what is the secret? Temperature volume, pressure volume relations. Next in module 2, exclusively gas turbines and jet propulsion. Remember in jet propulsion, you should learn the theory of 4. What are those? Turbojet, turbopropeller, ramjet and pulse jet. Okay, any one question you can be expecting in the examination. So that is the secret for first 2 modules. Then module 3, vapor power cycles. Please start practicing the flow diagrams and TS plot for 5 prominent cycles. Which are those? Number 1 is Carnot cycle, second one is Rankine cycle, reheat cycle, regenerative, then combination, Rankine reheat, then reheat regenerative. So when you practice the flow diagrams, I can promise you that any problem you can solve it. So we have already posted the problem solving sheets to all WhatsApp groups of 4th semester. Please see to that. Bear in mind, one should be very well acclimatized with the use of thermodynamic data handbook. Okay. So next, 4th module, refrigeration and air conditioning. Yes, in gas turbines pressure ratio, even in refrigeration pressure ratio, T2 by T1 equal to P2 by P1 to the power of gamma minus 1 by gamma. Okay, so 3 prominent refrigeration systems: air refrigeration, vapor compression refrigeration, vapor absorption refrigeration systems you should learn. Okay, then air conditioning, I have told the secret. Lastly, reciprocating air compressors. Okay, even in that, which is the prominent relation? Yes, you are right. That is temperature pressure relation. Okay. So friends, please practice the complete theoretical details of all modules. Also, I have posted the problem sheets to the WhatsApp group. I have written the question, the complete solution also it has been covered. You please start studying rigorously. In the coming days, we will be having online interaction sessions. I will be posting the video lectures and many more. Okay? With this, it is the high time to say good night to you all. Thank you very much.